Just all sorts of messed up with it.
Whoa. Color show.
Craziness. So here we go. In order for us to solve these log equations, there's going to be a couple of properties that work. And I don't want you to write out the properties or anything like that. What I want you guys to see is that in order to solve these equations, when you have exponents, once your bases become the same, that means your exponents have to be set equal to each other. So your objective here to solve these types of problems when you have exponents that have variables is to get a common base. If you get a common base, it's that idea of that, excuse me, you just set your exponents equal to one another. It is a very, very easy thing to do. So if I'm looking at this problem here, where I have a 4 to the 3x and 8 to the x plus 1, what's going to be a common base that I can rewrite 4 and an 8? 2. Good. So if I rewrite the 4 as a common base 2, it becomes 2 to the 2 times 3x equals what?
3 times
And the one thing you're going to screw up when you do that?
doing the 1.
You're going to forget to distribute the 3 to the 1. Okay. So, do I have a common base?
Yes.
When I have a common base, all I have to do is set my exponents equal to each other and solve. That's it.
So they just cancel out?
Yep.
Okay.
Because what we're going to do is we're going to take the log base 2 of both sides. Because if you take the log base 2, what happens to those? They simplify out. I'm taking the log base 2 on both sides by keeping the equation balanced that way. Exponents fall. We just don't write it. So you get 6x equals 3x plus 3. Variables on both sides of the equation. What do you do? Oh no, I don't know if I can do this. This looks very scary.
3.
You will eventually. Little miss, I can do this without my calculator.
Me?
Notice how you said it. I thought you needed her calculator.
You do.
You will eventually. Okay. They're not always this easy and clean. All right. Not bad though, right? Get a common base, things fall because you're taking that log base on both sides. You don't need to do 2 of them, let's do 1 of them. You don't see them. 9 to the 2x, 3 to the x minus 4.
6.
6.
You just tested us.
I was. You've all passed. What's going to be my common base here?
3.
3. So I only have to change one of them. So the becomes 3 to the 2 times the 2x. Is 3 to the x minus 6.
Yay.
Do you have the same base?
Yeah.
What happens to your exponents?
Good
They
job.
drop. 4x equals x minus 6.
Negative
3x.
You're swimming with your calculator. Something about a calculator in there? And so it begins. All right. Once again, what's something that you can do very easily to check your work? You can substitute back in and stuff like that. Morning, Mr. Tuna. How are you, sir?
Good morning.
Oh no. Honestly, you're all right. You know my lines. They're not very original. Same basic idea in here. It is supposed to be an exponent. It's tough to type, so that's why I... In this case, it's 2 to the x equals 7. Now, I cannot rewrite 7 as base 2, can I? When this happens, this is when you have to actually use your calculator. You have to log. So now, in order to get this exponent to fall, what's the log base that I have to take on both sides? Log base 2.
What? Say why?
You know he's got locked.
What happens here is you get the log base 2 of 2 to the x. That undoes it. That undoes the exponent, therefore the exponent drops. So x is going to equal the log base 2 of 7. Do you guys remember how to hit the log base button in your calculator?
Alpha.
Window
5.
Alpha window 5. 2 decimal places are fine. I always like to go bless you.
Bless you.
If it's 2 decimals, round it to the nearest hundred. What do you guys get? I watched you do it. I watched you start to go. I'm like, it usually counteracts the sneeze, so this time it failed. What'd you get? 2 equal.
2.8073549.
Dude, come on, 2 decimal places.
Not the 100th decimal place, the 100th.
Try.
Shut.
Oh my goodness. This is so scary. What am I gonna do?
Oh, you subtract 4 for both sides.
Now it becomes a, you guys, all right, I'm not mean to you. Okay, be back.
You're mocking yourself.
I am,
How would we
yes.
mock you? It's not okay.
You subtract 4.
Yes, but you have to move stuff around before you can log on both sides. Yep, subtract 4, you get 10 to the 2x minus 3 is 17. Now, what log base do you have to take?
Just 1.
10.
10. Oh.
So do you have to type in log base 10 of 10, or can you just press log?
You can just press.
In this case, you can just log it. So let's see, 2x minus 3 equals the log of 17. Now, before I go to do all this in my calculator, does everybody agree in order to solve for x here, the first thing you have to do is add 3 and then divide it by 2, correct?
Yeah. So to be like.
So we get, see here, x is going to equal log of 17 plus 3 all over 2.
Wait, would you add the 3 to the 17 or no?
No, because the log of 17 is an exponent, remember?
Okay.
So in your calculator, you just type in log 17, close the parenthesis, plus 3, hit enter, divide by 2, hit enter. 216.
Log 17.
You messed up your numbers again.
No, we didn't.
What's wrong with it?
I got 2, 1.
What is going on?
Right, so it's 2.1.
Mr. Murphy.
Oh, wow. Oh, wow.
Cullen, quit talking.
Hey, Jared.
Cullen didn't
Okay, anyway, you cannot add 3 to the 17
No, I meant like do log.
and then hit enter? Yes. Like I said, this isn't very scary.
No, actually, that's what I said.
Oh no.
Hey, you could make that a base 10 though. Because it says the -1.
Now you're trying to mouth off. You guys are going to miss it when you have to deal with Mr. Taves' bad jokes.
True.
Oh, true.
I see you when I came back.
Wait, what?
Hey, Mr. Murphy, you say you don't know who's speaking on.
We won't know until the springtime. Don't know how many sections there are. I don't know who's doing what. What do you have to do first?
You log. Yes. But couldn't you just say that 0.1 is like 10 to the -1st power?
Sure. But I'm using my calculator for this, so it doesn't really matter what I do. So I just hit log of 0.1. Add 4. Divide by 3.
1.
You know, it's the loneliest, huh? Thank you. Now,
Wait, what was?
1.
Whoa.
Somebody was gonna say it.
What do you think?
Yeah.
1.
Take a look at what happens here. I have log base 3 of something equal to log base 3 of something else. The only way this is going to be able to set up if the somethings are the same.
Yeah.
So you got a factor?
No, you're not factoring anything here. Do we have the log of the same base on both sides?
Yeah.
Okay. To undo a log, what would you do?
So, I mean, if.
Exponentiate it.
Well, I mean, could you just say
What
like.
you're doing here is you're raising it as an exponent. Now remember, when you have a base to the log of the same base, remember how that exponent would fall? In essence, that's how this gets undone.
So you just put it
Nope,
Basically-
nope. All this becomes is, by doing this little step, are these two bases the same?
Yeah.
Yeah.
Therefore, 5x minus 1 equals x plus 7.
And so then,
This is how you undo the exponent. It's going, instead of logging on both sides now, we're turning the log into an exponent, so we're exponentiating it.
Oh, so the log is the exponent of 3?
Correct.
And so that cancels it out?
Yep.
Could you just say that like, since
Okay.
5x, since they make the same answer, could you just say that 5x minus 1 is equal to x?
It's exactly what we're doing here. This is exactly what it is, because the rule is, in order for it to work, if these two are set equal to each other, the only way that they can be equal is if
Okay.
that happens. I'm showing you how this works because you'll have to use that eventually. Okay? Yes, sir?
is there ever going to be different bases?
No, it won't work. Okay? Now, what do you guys get with this then? 2? Bring the 4, add the 1. Okay? You get that? You all right? So now what happens? Now what do you do?
Get rid of the log, just exponentiate.
You exponentiate it, correct. You have log base 2 of x plus 2 equals log base 2 of x squared. This is not insulting. I know it is, but I'm just showing you how it goes. I'm not trying to insult you. This is insulting. Ouch. We have the same base on both sides.
Yeah.
Do you need to write the step of exponentiating in this case? You don't need to do that. So you just have x plus 2 is x squared.
So just x is
Send it around. We have x squared minus x minus 2 is 0. What times what's negative 2 you add together to get negative 1?
1.
What?
And, okay, wow.
1, 2.
Wow, I think.
What are your two possible?
2, negative 1.
2 and negative 1.
Will it always be what you get, or do you have to check it?
I check it. I would absolutely check it. Now this one shouldn't be that bad because you get log base 2 of 4 and log base 2 of 4. Okay. Log base 2 of 1 and log base 2 of
1.
aren't they
Wow,
the
they
same?
both work.
They both work.
Wow.
Okay.
Oh, wow.
But that's a good idea though. You want to double check your solution because sometimes you will get that extraneous solution. Okay? I know, but it takes a second to press a button. I could make you get a log table if you want.
No.
Not
Wait, is that like when
Log table.
No, a log table is like a table, log table, and chairs. Is that what you're going for?
No, it's not.
I do.
I can get like logging like.
Yeah, okay.
Just quit while you're ahead.
I would be even more ahead.
Do I need to spend time on this one?
No.
Yes. Spend 30 minutes on
Yes,
it.
ma'am.
What will happen if they're
Step
not
by step.
Pretty good.
I would endeavor.
Oh, sorry.
Thanks.
We were just joking about how see all these logs.
Oh no, I was asking about your feet though.
Oh.
Oh, thanks.
It's not me this time.
Oh, boo.
Yo, when is this part?
Boo.
don't-
Did you even hear this?
Now
We're
I know.
stumped with this log stuff.
It's gonna be that, but on the test.
Hey.
Yeah, it was more creative. It was more creative.
Now, this is what we call, this is our exponentiating, okay?
Wait, did we skip that last one?
It is a real
They
word.
put the first.
Exponentiating.
No, oh, there is.
It is. It is a real word. I always forget.
It's too late.
In this case here, you've got, in order to make this work, just like when you had to take a logarithm of both sides to get the exponent to drop, here we have to exponentiate something to get the exponent, to get this one to drop. I have log base 5 with quantity 3x plus 1. In order to figure out this, to get this undone by the log, it has to be exponentiated. You okay on that? Now, if I do it to this side, I have to do that over here as well. Now, 5 to the log base 5 of something, that exponent falls. You get 3x plus 1 is going to equal 5 squared. 5 squared?
5 squared. I was thinking 2
I know.
squared.
That's okay. And you get 25 on the other side.
That's weird.
That's
X is 8. There's really not a lot to this. Okay? Not a lot to
This
this.
is a nice unit.
I think so.
No, there has to be at least 1 or 2 words.
Log base 2 of x equals negative 1.
Wow, what am I going to do?
If you're going to do it, you got to sound a little bit more sarcastic.
Oh, no.
There, that's it right there. Oh no, I don't know what to do. I need time to process this, because it is horrible. Please, help me. Oh, mathematics. Maybe. All right, here we go, multi-step. Whoa.
Oh my goodness.
And then just
Mr. Murphy, I'm taking recordings of all the times you've done that, and you make like a rap out of it. Like, It's just gonna like, it's gonna be like the theme song to the class. I swear to God.
It's hilarious.
It's like there was a tally sheet in Mr. Fontana's room. A few years ago, somebody tallied the number of times he clapped. He claps.
Oh yeah, he does.
They tallied the number of claps throughout the school year.
That person must have.
Had perfect attendance.
had a lot of time.
Wait, what
We
was
used
the
to do
number?
stuff like that.
How many times?
Yeah, I don't know.
Did that.
Not to the end of the year. I once did that to a college professor that did this all the time. It was the only way I could focus on anything in that class, was to count. What's your first step?
Subtract 15 from 5.
Subtract 15, good.
Then divide by 2.
And so it'd be technically wouldn't be log 2 x squared, right?
It's 2 times the log, right?
You just
How do you do it? Divide it by 2.
Well, maybe I wanted to square root.
What's that? No, nothing's canceling out because it's not
It's not the base.
below, it's not the base. It's not exponentiated. It's 2 times that. You'll see the difference between when it's exponentiated. Is in the book they tend to over-exaggerate where the log is. They tend to raise it up that much higher. Okay? So now you just divide out by 2. Now you exponentiate it.
And then it's 2 to the 8th. I got it.
Well, hold on. 2 to the 5th is 32.
256.
Why can't you guys do this in your head?
Because we don't need to now. We don't know. Because it's too high.
256.
Oh, I know.
Oh, I get it.
Oh, no.
That's crazy.
It's 256.
Oh, it's 3 to the 5th. Oh, Mr. Murphy, I have a question about that.
Yes, ma'am.
How do you do the natural log?
It has the same properties as log.
So
You treat it the same way.
28, 14.
Yeah, perfect. That's exactly what it is. You're not insulted anymore?
No, I'm pretty sure you're still insulted. This is deep radio. No, this is.
What do you have to do first?
exponentiate.
We're trying to make this 27 plus 1, 28, divided by 2. Here's 14.
That's equal because you have
A little bit, yeah.
Whoa. What is that?
Now, this is where things can get a little bit messy. When you wind up with your extraneous solutions. Okay? So you have log of 5x plus log of x minus 1 equals 2. At this point here, I cannot exponentiate this because of why? The plus sign? Because of the plus sign, good. So what should I have to do for that? Condense it, yeah. Condense it on the left side first. What I mean by that is rewrite it like you guys were doing the last couple of days. So you wind up with the log of 5x times x minus 1. Brackets would do that better. And then now that equals 2. You okay with that? How do I undo just log? 10. Exponentiate it with a 10. Yep. So now on the left-hand side, we get 5x squared minus 5x equals 100. You okay with that? Move the 100 over. Take out the 5. Very good. The reason why I'm taking out the 5 is why? And it's your first rule of factoring. Take that GCF out, just makes it a lot easier. Since I'm looking for zeros, does that 5 have any bearing upon the rest of the problem? Because of why? What could you do?
Just divide each side by 5.
You can divide out the 5. Good. All right. What times what's negative 20? You add together, get negative 5. Negative 5, positive 4. Good. So x minus 5, x plus 4. Two possible solutions, therefore, are at 5 and negative 4. Once again, when you get two solutions like this, take a minute, double check. Okay? Our original problem, I believe, was, so we have log of 5 times 5, so log of 25, plus log of 4, I believe. Okay, I'm just simplifying it right away. Did that equal 2? 20.
Wait, can't you just do
Yes,
it
it
as
does.
5x minus 1 equals 100?
Yeah, if you want. I'm just going to the original, because what happens if I screw something up? You're still confused?
Wait, why did you put in
I'm testing those at 5,
No.
and then I'll test them both at 4.
Okay, it added -4.
Okay? What's that? -4, thank you. Sorry. And you should notice right away you're going to take a log of a negative. I don't think you can take logs of negatives. Non-real answers.
With the 5x minus 1 and then -4 in a row, it multiplies the equal.
Right, that's when I go back to the original. So what happens here is you always go back to your original equations when you guys are starting to do your checks. You're right, if you go back and put -4 into here, it does simplify itself out. But you go back to your original, it won't. Okay? So your only solution will be 5. You have that extraneous solution at -4, so we just cross them off. Not necessarily, because what happens was at -4 was your solution, and this was +7. -4 plus 7 would work. You always, I don't want it to be pigeonholed into just be the negative answer won't work. It could be. You don't know. You have to check it. All right. So good question, guys. Should you always just get rid of the negative answer from the possible solution? No, just take 30 seconds and double check your answers, okay? It's really all you got to do. All right?
No,
I don't either.
yeah, I know.
Good day. Are we okay? It's not that hard.
It's not that hard.
Do those. No! You saw how easy this stuff is. Put your one
You just
in.
make it so we don't have to write all that out.
Take a picture of it.
You're right. Isn't that 31 through 41 odd? Oh no.
No, there's a 36 in there. I don't know much about numeracy, but that might be something that's not.
Watch out.
You guys complain a lot. You should make this stuff harder.
They do complain a lot. Wait.
I'm